we are going to write equations of lines given some various information. So some information that we will be given is the slope and y-intercept. And when we have the slope and y-intercept, we just plug into the y equals mx plus b. The next one we will have is a point and a slope, which you're going to use the point slope form. And then the last one, what do we do when we have 2 points? Okay, so when we use 2 points, you find slope and then you use the point slope form. Because after you find the slope, you'll have one slope and 2 points. You're just going to have to use one of those points with the slope to go back up to the point slope form. So let's go ahead and begin. Find the line with the slope of -5/2 with a y-intercept of 3. So we are just going to go y equals -5/2 x plus 3. And we're done. We have a slope, we have the y-intercept, now we have an equation of the line. Let's find one with slope of -4, y-intercept of 1. That's going to be y equals -4x plus 1. And we're done. One more. Slope of 2/5 with a y-intercept of 11/3. So y equals 2/5 x plus 11/3. And we are done. So anytime you have a slope and a y-intercept, you plug them in. Now the y-intercepts can be written in the form of a point. So sometimes when you have a point and a slope, or 2 points, and one of them is your y-intercept, as soon as you have your slope, you can go ahead and plug in your information. So let's go ahead and use the point slope form. So the point slope formula is y minus y1 equals our slope times x minus x1. This y and this x stay as yx. You're going to have a point of x1, y1, and the slope to work this with. So let's find the equation using 2, 1 as a point with a slope of 2. So y minus y1, which would be 1, equals slope, which is 2, times x minus our x1, which is a 2. And I love using the point slope formula because when you solve for y, any of one of these you do, you're going to distribute and then add or subtract. So we're going to distribute and then add the 1 over, and we are done. Okay, so let's look at the point -3, 3 with a slope of 1/3. So y minus 3 equals 1/3 times x minus -3. And anytime you plug in a negative number, make sure you put that in parentheses. It'll make it a lot easier. So distribute. So 1/3 of 3 is 1. Add the 3 over. Y equals 1/3 x plus 4. Okay, so we have the point 0, -5, and the slope of 11/6. We'll have y equals 11/6 x minus 5, because this is actually a y-intercept. So we have a y-intercept of -5 and a slope of 11/6. So even though you get a point and a slope, don't always use the point slope form when you have a y-intercept here. If you wanted to, you could have done y minus -5 equals our slope of x minus 0. So we have y plus 5 equals 11/6 x. Subtract the 5 over, and you still get the same result. You just did extra steps. Okay, so let's look at 2 points. Find the equation of the line with 2 points. Three, 6, and 2, 4. Okay, so we have 2 points, but no slope. So we need to find slope. So 6 minus 4 over 3 minus 2. I labeled them this way: x1, y1, x2, y2. And that's okay if you want to switch them around. So you have 2 over 1, which is 2. So now we have a slope. We have 1 point. I'm going to use this point and this slope to help me. Y minus 4 equals 2 times x minus 2. Distribute that 2 through. 2x minus 4. Add the 4 over. Y equals 2x plus 0, or just 2x. Y equals 2x. Okay, let's work this one. Actually, let's turn this into a 4. There we go. That will be easier. I don't want to cause more headache than what we need. I'm avoiding a lot of fractional slopes for you guys. So 4 minus, or let's go -4. -4 minus 3 over 6 minus -1. Okay. Yes. So -7 over 7, we get -1. Okay, now we have a slope. We pick a point. I'm going to pick that point. You can pick the other point if you need to. So y minus 3 equals -1 times x minus -1. X minus 1, add the 3 over. Y equals -x plus 2 is our answer. And if you would need to, you could put -1x if you'd like. Okay, 0, 3, and 5, -2. So we will have our slope as -2 minus 3 over 5 minus 0. We have -5 over 5. Oh, that's actually going to give us -1. But if we use our point and a slope, we actually have our y-intercept here. So since we have our y-intercept and a slope, we can do the very first thing we did and just plug in our values. So sometimes it gets a little tricky because we actually have our y-intercept and we have our slope. So when we do that, sometimes we just mindlessly go through the motions of the point slope form. But this will create higher level thinking of actually identifying your point or one of your points as a y-intercept. let's look at this one. Let's find our slope. 6 minus negative 2 over 3 minus 3. 8 over 0. This is an undefined slope. If we have an undefined slope, that means our x's are repeating. So this will be x equals 3. That is our line, and we're done. So if we have an undefined slope, our x's are repeating, x equals 3. Okay, so let's look at these 2 points. Let's find the slope. Zero over 8. We have a slope of 0. You can go ahead and put the slope and a point in your point slope form, but this it will be simply y equals 6. As you can see, we have a repeat of 6 in our y, so y equals 6. So this is actually a vertical line at 3, and this is actually a horizontal line at 6. If you get 2 points and you identify that your x's or y's are repeating, then you can simply just put your slope is undefined or slope is 0, and then state x equals 3 and y equals negative 6 if you can identify that right away. If not, then go through the motions, use a point, use a slope. This one, since it's undefined, it's hard to put that into your point slope form. It just won't work. But putting 0 in will still work. So, and that's how you write equations of lines using the 3 different pieces of information that you may be used, or 3 different combinations of information you can be asked.